Here we go. If you flip to the back of your notes, I'm going to remind you how to multiply. It says find the product. Your next review quiz is over multiplying polynomials and then eventually dividing. So we'll talk about multiplying first. If you look at numbers 1, 2, 3, and 4, what would you do? Distribute. 5 and 6 are similar to this one. They're not the same problem. How do we multiply a problem like this? There's an acronym for it. I use this when I'm baking cookies. I lay it down on the...
Flour.
Not flour.
No.
Foil.
Oh.
Guys.
Oh, first outer inner.
Foil. Yes, Tito. First, outer, inner, last. But first, what is 3x times 4x? 12x squared. It's okay, so I refresh. Then you do outer, 3x times 7, which is 21x. Thank you. Inner, which is negative 2 times 4x, which is. And then last, which is negative 2 times 7, which is. All right, do I leave it like this? No, I got to combine like terms, which would only be the 2 in the middle. So I'm going to drop down my 12x squared. What is 21x minus 8x? 13x. Is it going to be positive or negative? Positive, and then drop down the 14. Can I simplify this any further? Nope, that's it. So just to refresh your memory, your next review quiz is in like 2 or 3 Fridays, whatever the 8th is. And it's over multiplying, and then I'll show you dividing. You know how to divide. It looks like 5x minus 10. And you divide out of 5. Does this look familiar? Yeah. So you know how to do both. It's just we're refreshing it all before we get back to factoring. All right. So if you look on the front, this is a beautiful depiction of our boy Pythagoras. He's the father of numbers. So you see there's a big blank section. This is where I'm going to take out the bonus questions for the next test. About Pythagoras, there are a few facts that are very interesting. He is known as the father of numbers. He's a very, very, very weird guy. But he made contributions. He's Greek. He made contributions in religion and science. In the real world, science is math. So when I say he made contributions in science, it means in the context of math, not like discovering trees or anything. His religion is like a cult. And it's very weird, and I cannot justify anything about his life. I'm just here as the messenger. I wrote a paper on him in college. He and Archimedes, very interesting people. He discovered the Pythagorean Theorem, and I really should put quotes around the word discovered. You know how, like, men in history, specifically apparently white men in history, they, like, come upon something that is not named, and they decide they're going to name it, even though it's already been around, you know? That's a Pythagorean theorem, and Pythagoras. They actually used it to build the pyramids. The Babylonians used it way before this guy was even in existence. But he came upon it and decided to name it after himself, even though it had been around for a very, very long time. Who else in history did this? We celebrate him a day in Columbus. So, very popular to do, but we call it the Pythagorean Theorem after him. So I'm going to tell you a lot of things about it's called a brotherhood, and then about how he died, because it is the weirdest way to die, and the dumbest way to die, I would say. But everything I tell you is from a textbook. You can get it off of Amazon for $11 if you so choose. The reason I tell you this, I know that's you really want to. The reason I tell you this is because a lot of students have many questions for me. And I'm here to tell you I don't have all the answers. But you can research exactly what I researched. From this textbook. It has a ton of things about him, the life and philosophy. These two men wrote it and took writings from Pythagoras himself. So, that being said, in his religion, just ignore these two for a second. Well, it'll make sense. In his religion, new initiates had to stay silent for 5 years. And here's why. Okay, he believed that in silence you come to the deepest thinking, which I would happen to agree. Think if you had no Netflix, if you had no phones, if you weren't allowed to talk to anyone, have any conversations, you had nothing to do besides sit and think. You'd think pretty deep. You would probably go a little bit crazy. Now, I'm not sure how this worked, if they had to go to the market, or if they were sick, or if they were allowed to talk in their house. I don't know. But his rule is that you had to stay silent for 5 years. And then he was a vegetarian because he did not want dead carcass in his soul. He also didn't want beans in his soul because he felt that beans and people had the same origins. So they were connected, and it'll be the lead to his demise. No joke. So remember that. Okay? But, yeah.
He dies from hunger.
He does not die for hunger, unfortunately. But he does die because of the bean. He lived by the bean, he died by the bean. I'm telling you. He and his followers prayed to the divine number 10. Why the number 10? I don't know. How do you pray to the number 10? Still don't know. I'm just telling you. Research. They sound like great people.
Is this the lesson today?
We're going to talk about the Pythagorean theorem.
This is better.
So you know how back in the day the Greeks had a lot of men that were very smart and they had a lot of followers, like Plato, Aristotle, Socrates, Thales. He was one of them. That is why anybody would go to these lengths, because I sure wouldn't. They had a sacred symbol. It's called a tetractys. So if you saw the symbol, it was like their logo. It's basically a bunch of triangles. And then there is a legend, and all legend is based off of some sort of truth. The legend says he killed a man for discovering an irrational number. Yes. Pythagoras had this belief that there were only rational numbers in the world. He believed rational numbers are whole numbers or fractions that turn into decimals and don't repeat. So like 1/2 is 0.5, 1/4 is 0.25. 1/3, not a thing, because what's 1/3? 0.3, or 2/3 is 0.63. Devil's number right there. But he had a man disagree with him and tried to prove it to him that irrational numbers exist. Irrational numbers could be used in the Pythagorean theorem. And so legend says that Pythagoras slit his throat. It's a good time. It's a good way to end an argument, I guess. I don't recommend it. 0 out of 10 recommendation. But I'll tell you how he died. This is our guy right here, Pythagoras. He doesn't really look like that, obviously, but if you look up old guy clip art, he would pop up. This is where they all lived. This is where they met. Pythagoreans. We're all using our imagination. Okay, so this was a very elite group that people wanted to be a part of. And so those who couldn't be a part of it, they gathered together and they decided to rise up and fight against or murder, I guess. So they burnt down the building where they met. Pythagoras escaped, right? He runs away. And then here comes this field of beans. Now, remember what I said. You live by the bean, you die by the bean. So he stopped, and he honestly looked at the beans. Remember, he thinks that there is a connection between humans and the origin of beans, right? So he said that I would rather die of slaughter than run on beans.
So he killed him.
And so he did. No, they killed him. In the book, it says there's blood spatter among the beans. So, anyways.
Did he actually say that? Like that?
Well, yes, but in his little language.
Senior quote.
I've been asked that all day today. Oh, and he wouldn't eat beans. So I don't know how he didn't have any. He didn't get any protein either. So he probably wasn't very healthy. Because if you're a vegetarian, you get your protein from beans. All right, so we're going to talk about the Pythagorean theorem. Our book is weird, and it says c squared equals. But we can do a squared plus b squared equals c squared, like normal people. Which one of these represents the hypotenuse? c squared. So the hypotenuse is always c, and the hypotenuse is always opposite the right angle. What else do we know about the hypotenuse? It's the longest side, yeah. So longest side, and it's always across from the right angle. I'm just going to show you where we get the squares from. This is how they did it before they had a name for it, before they had letters for it. You would line up a perfect square on one side, a perfect square on another side, a perfect square on the third side, and you would know you had a right triangle. But that's where the squares come from. This is a 3x3, 4x4, 5x5. There's a thing called a Pythagorean triple. It'll make sense when we decide in our next section if we have Pythagorean triples. They use these a lot in construction. They actually memorize them. Not on purpose. What that means are these are all whole numbers that satisfy a squared plus b squared equals c squared. So if I plugged in 3 squared plus 4 squared, it would equal 5 squared. If I plugged in 6 squared plus 8 squared, it would equal 10 squared. See what I'm saying? So these are like the most basic. My husband told me on job sites, I did not know this until I was talking to him about Pythagorean theorem. They actually memorize them because you have to use them so often in making right angles. You use them ceilings, floors, literally anything in life has to make a right angle. The most common is 3, 4, 5. I would know that somewhere. 3, 4, 5. 3, 4, 5.
Why is she winking?
I don't know, but it honestly hurts my eyebrow to wink and to smile because then it like raises it. It is what it is. Anyways. So, find the value of x, then tell whether the sides form a Pythagorean triple. So basically, if all the sides are whole numbers, then it is a Pythagorean triple. So you're going to have 2 answers. So that's what we're looking for. In numero uno, we know we're going to use a squared plus b squared equals c squared. Am I missing a leg or a hypotenuse?
Hypotenuse.
The hypotenuse. So that is what I'm going to plug in for C. Does it matter where I plug in 81 and 108? Well, not really. Well, I'm saying between A and B, it doesn't really matter. You just pick one. So 81 squared plus 108 squared equals C, which is x squared. All right, so this is where you're going to need a calculator. Your calculator doesn't have a square button, but what can you do to square 81? Multiply it times itself. So 81 times 81 is, good question, right? 6,561. Is that what you said? 108 squared. I think it's 11,000 something.
1166.
Equals x squared. All right, so we add them together, and I believe that's 18,225. All right, so how do we solve for x? Take the square root, because it's the opposite of squaring. So x equals 135. Oop. So the last part would be, is this a Pythagorean triple? Are all 3 of these sides whole numbers? Yeah, so then you would write yes, and that would be the second part of your answer. You did. You learn a lot of math over and over again. In number 2, are we missing a leg or a hypotenuse? A leg. So when I do a squared plus b squared equals c squared, I plug in for a or b. My other leg is 4. Then my hypotenuse is 8. So this one you need a little bit of algebra to do. What is 4 squared? 16. And 8 squared is?
64.
Subtract 16. X squared equals 48. You're good. And then take the square root. This is not a perfect square, so you will get a decimal. Go ahead and round to the 10th. What do we get? So 6.9. And then is this a Pythagorean triple? No. So I'm throwing it out there on your classwork. One of them rounds up to a whole number, but since it's a whole number and a decimal, it'd be like saying 7.012456789. That is not a whole number. It still has a decimal. Does that make sense? So in order for it to be a Pythagorean triple, it has to straight up be a whole number. That makes sense? And then number 3, you guys are going to try by yourself. I will say we don't do as much algebra as you do in Algebra 1 with this. Because I remember y'all doing like x plus 1 was a side and you had a FOIL and all the junk. We don't do that here. Are we missing a leg or a hypotenuse? Hypotenuse. So we plug in 15 squared plus 20 squared equals x squared. What is 15 squared plus 20 squared? I believe it's 625. Equals x squared. Take the square root. X equals 25. So is this a Pythagorean triple? Yes. Ooh, I got to make this even. That's better. All right, so there's that portion. We're going to do a word problem. From school, you biked 1.2 miles due south and then 0.5 mile, that sounds weird to say, 0.5 mile due east to your house. So here's what I'm going to remind you if you don't know, which is fine. We all know north, south, east, west. But when north and south meet east and west, they are actually perpendicular. Or they wouldn't be for completely opposite directions. Okay? So whenever we do a problem like this, north, we're meeting south and east, where south and east meet is a right angle. So that's where it ties into a right triangle here. So we're going to start at the school, just like it says. So I'm going to put a dot and call it school. So from school, you biked 1.2 miles due south, which would be down. So 1.2. Then you bike 0.5 miles due east. So 0.5 due east and to your house. So that's my house. Where they meet is a right angle. If you had biked home on the street that runs directly diagonal from your school to your house, how many fewer miles would you have biked? So we're trying to figure out how many miles we would have biked if we had done the diagonal instead. How many miles did we bike in general?
2. Wait, no.
We biked 1.2 and then 0.5. So we biked 1.7. So we're going to figure out how many we could have biked if we had done the diagonal. So what do we think we used to solve this? Yep, Pythagorean theorem. So a squared plus b squared. All right, so am I missing a leg or hypotenuse? Hypotenuse. I'm going to plug in 1.2 and 0.5. It equals c squared. So we should get 1.44 plus 0.25 equals c squared, which is 1.69 equals c squared. So what's my last step? Take the square root. So the length we could have gone was 1.3. So how do I answer this question? How many fewer miles would you have biked? Subtract. So 1.7 minus 1.3 is 0.4, and I would put an S. I don't know. It sounds weird to say 0.4 mile. I don't know. I'm sure it's not grammatically correct, but don't you think it sounds weird? 0.4 mile. Anyways, this is almost half a mile. So I think it's a significant distance. We're going to flip. This is the last concept. So you're going to be using the Pythagorean theorem to prove that a triangle is a right triangle. If you look at the top, you have two examples. Just because it looks like a right triangle does not mean it is a right triangle, because an angle that looks like 90 could be 91 degrees or 89 degrees. So what you're going to do is plug into a squared plus b squared equals c squared. The issue is, if I looked at letter A and wanted to plug in my sides, which one looks like not fun to plug in?
Square root of
The square root.
113.
So I'm going to remind you how to do these things. My last class remembered automatically. But in case you don't, I'm going to show you with these three examples. And the last two are especially helpful if next week you have this scientific calculator. If you plug it in wrong, you'd be wrong. So I'm going to show you the difference in the second two. But in the first is going to help us figure out how to square a square root. Squaring and square roots are opposites of each other. They undo each other. So I'm going to show you why it is the way it is, but you just have to remember what the answer would be, if that makes sense. When something's being squared, what is happening? It's being multiplied by itself. So this is technically the square root of 5 times the square root of 5. So when you multiply radicals, you multiply the number underneath, and you keep the radical, Tito. So it'd be the square root of 25, which is 5. So the property is, or the thing that you would want to remember, is that when you square a square root, they cancel each other out. And the number under the radical is free, I guess, whatever you want to call it. So this is the thought process, but you don't have to do this process if you don't want to. In the second and third, what is the major difference between the two?
The first one you're multiplying the number outside being under the radical, and the second one you're just multiplying under the radical.
Yeah. So in the first one, the square is applied to both the number and the radical, whereas this one is just applied to the radical. This is the one you would want to plug into your calculator, because when you square a side of a triangle, you're squaring the entire thing, not just the radical. So if you look at letter B, you have 4 square root of 95, I think it was. You need to make sure you put parentheses around something like that. But I'm going to show you how to do it anyways. What is happening when you have a number in front of a radical? They're being multiplied. So technically this is 2 times the square root of 3 squared. I didn't do anything, I'm just showing you what it technically is. When you square, you want to square both the number and the radical. And then you simplify. What is 2 squared? 4. And the square root of 3 squared? They cancel. So 3. And then 12. Oh, sorry. And then 4 times 3 is? 12. All right, whereas the second, we have 2 times the square root of 3 squared. So keep the 2. What is the square root of 3 squared? 3, which would make 6 instead. So make sure, if you ever have to plug it in your calculator, you have your parentheses. And make sure when you don't have your calculator, you square the front and the radical. Because technically I haven't decided whether you're using the calculator on this part of the quiz or this part of the test. Just the trigonometry, sine, cosine, and tangent. You have to use a calculator. That makes sense? So, all right, so we're going to do these two and then we'll be finished. We're proving or verifying a right triangle is a triangle, or a triangle is a right triangle, speak. So you want to plug into a squared plus b squared equals c squared. Which one looks like it could be the right triangle? Or the, wow, words. Which one looks like it could be the hypotenuse? The square root of 113. So we're going to call that our hypotenuse. And plug the other two in as legs. So we'll have 8 squared plus 7 squared equals the square root of 113 squared. 8 squared is? 64. 7 squared is?
49.
And the square root of 113 squared is? 113. All right, and then last, 64 plus 49 is? 113. It equals 113. So is this a right triangle? Yes. So what you would circle is all of it, like all of the last sentence. Because a lot of students just guess, and I would like to see your verification. In higher up maths, you'll verify a lot of things. In calculus, you verify a lot of things. All right, letter B. Which one looks like it's going to be the hypotenuse? This is my hypotenuse. So that means these two are the legs. This is where I need a calculator for the squaring. So notice again I have my parentheses around my radical at the end. What is 36 squared?
1,200.
Then 15 squared is 225. All right, and then I'm going to square this up here. When you're squaring the front number as well as the radical. All right, so what is 4 squared? 16. And then technically it's times. What is the square root of 95 squared? 95. Is it 2,000 or 1,000? 1520. 1520. And the right side is, no, that one's 1521. Right? And the right side's 1520? So does the left equal the right? No. Then you would circle both. That's all we're doing today. We will use it tomorrow to figure out if a triangle is an acute, right, or obtuse.